Hi everybody, so this is my little video to cover what we're going to be doing in labs for this badge. So I'm just going to quickly review what's available for this section, what the labs are, so you can know what you're getting into as you choose which labs you might want to do to earn your lab points. So I'm just going to go ahead and share my screen so we can start looking at the different labs. So the first lab that's available, and this one was one that was a possibility for your planetary science badge, but I'm reopening it because of the smoke, was the Measuring Earth lab. So this is the one where we measure the mass and the radius of the Earth. So if you want to do this one, the funky thing about this is that you have to do it at noon, and the closer you can do it to the equinox, the better. So the equinox was the 22nd. So this one, if you want to do it soon, because that's going to get you the best measurements of Earth's radius. Then you use gravity in order to get the mass of Earth. It's a little math heavy, but I'm happy to help you with any points. So please don't be afraid of that math. The other one from the planetary science badge that I'm leaving open is our determining the composition of Saturn lab. So this is the lab that I kind of mentioned today, where we use the angular size and the orbits of Saturn's moons to find the mass and the volume of Saturn and use that to predict a density. So this is another one that's a bit more math heavy, and it's from our last section, but because I was keeping the Earth one open, I wanted to keep this one open as well for fairness. So again, slightly more math heavy. You can do this one whenever you want. No equipment required. All you need is your brain and, you know, a calculator, but the internet has those. So it's a fun one. You get, if you can do it, if you can get through it, you can get the right answer, which I think is really cool. And I'm always available to help. Like I said, this one's a bit tricky, so definitely feel free to use me or your classmates to help you get through this one. The next lab is the inverse square law lab. So this is a lab where we use our iPhones or Android phones, any kind of smartphone or pad, smart pad, tablet, sorry, I forgot about that, that can download apps. You can download something that will measure the brightness of light. I did it with the Google Science Journal. There are other options. If you are having trouble with this app, let me know. We can find you a different option. But what you'll do here is you'll set up a new experiment on that, and you'll measure the brightness of a light as you move further from it, and use that to try to find the inverse square law by pointing that brightness versus distance. The next lab is the one that's going to require that lab equipment. So it's going to look like this, which is our diffraction grating. And we're going to use this diffraction grating to measure spectra of the lights around you. So you hold it up to your eye, you tilt it back and forth, and you can see spectra of different lights. Don't look at the sun, but you can get a solar spectra by getting a white piece of paper and looking at that instead and tilting it around. I also ask you to go outside and look for neon lights. So these are going to be like open and closed signs on restaurants. So if you are downtown, you can just pull this out and look really cool as you check out their neon signs. So not much math, but you do have to get outside. The next lab, which is available now, but we haven't quite covered yet, is going to investigate using parallaxes to measure distances. So we'll talk more about this, but this is looking for shifts as we move around the sun, or as you move to a different location, shifts in an object's position. That will give us a distance. So we haven't quite gotten to this one yet, but I wanted to just give it a brief shout out because it is a little more confusing, and it does involve going to a location where you have a view. So first you start out at home and you make an angular size measuring stick. So this walks you through how to do that. You calibrate your measuring device. That'll tell you what a degree is for your arm length. And then you'll use that at your place with a view to find the shift as you move back and forth, just like we do to find the distances to stars. So we haven't quite covered this yet, but we will. And this is a good one to try to test that out and see where it's going. I also tried to highlight all the questions that need an answer, so you shouldn't miss them, but there's a lot of information in this one. The other lab that will be available now soon-ish, sorry, I haven't quite opened it up yet, but it will be available soon, is our sun lab, observing the sun. Because we can't actually look at the sun with our eyes, and I can't take you to where there's a solar observatory, we're going to use some current images of the sun from the NASA Solar Dynamics Observatory here. And you're just going to check those out and use what you can see there to see what's happening on the different layers of the sun. So teensy bit of math, mostly it's just analyzing images here, nothing too terrible. And then also some counting of sunspots to try to measure that solar cycle, and also looking at the solar spectra. The last two labs for this section are our HR diagrams lab, which we'll use, we haven't quite talked about this yet, but it'll do some plotting of stars to figure out the age of a cluster. So this one, really the main thing that you're doing is you're doing some graphing and using that graphing, comparing it to some data to find the age of the Pleiades. And then there's also a lab where we'll focus on eclipsing binary stars and Cepheid stars. So this is the only lab that will use those NAAP labs that have the flash player requirements. This is the only one that requires that. So if you're struggling with that, this might be one to skip. But it goes through how we can get properties of stars based on how their light changes over time, either if they're in binaries or if they're Cepheid variable stars. So there's a little bit of graphing here as well, and a small amount of math, but mostly it's investigating those light changes in these stars. So those are your labs for this section. They're all worth 7 points, and you only need 25 points in your lab score, or you can get up to 25 points. So you only really need to do about 4 of them. You don't have to do all of them. You can pick and choose. And there will always be a Zoom link on Tuesday nights from 7:30 to 10, where I will be available to answer your questions. Of course, I'm also available during my office hours or over email if you have other questions about labs. Good luck, enjoy doing science, and I will see you soon. Bye.